Hello ladies and gentlemen, this is Mr. Cunningham, and what we're going to be talking about today is notes 14.3, which is over acid and base neutralizations. What I want you to do for me first is answer those bell work questions at the top of the page, then we'll get started on your notes. Alright, so now that you've had a chance to go over those bell work questions, what we're going to talk about first is our objectives and our goals. So sub-objective 1 says you should be able to identify a neutralization reaction. Sub-objective 2 says you need to be able to predict the products of a neutralization reaction. And then our goal, the thing you should be able to do by the end of this lesson, is be able to calculate the concentration of an unknown acid or base. So let's go ahead and get started. So basically all that a neutralization reaction is a reaction between an acid or base, or excuse me, an acid and a base. The products of that reaction are something called a salt and water. I know that you guys are used to, when you hear salt, you think of NaCl, like table salt. Salts are any metal and non-metal bonded together. So in this example problem, you see like NaCl as salt, but there are really multiple different salts, and we'll look at those examples. What I want you to also notice, a salt is an ionic compound, so metal and a non-metal. It's formed from the positive ion, which is called the cation, and that's from the base. So notice how here sodium is it is the positively charged cation. It is with the base. It comes over here and becomes part of the salt. Chlorine, or Cl, is the anion, or the negative ion, that's from the acid. So it comes over, those two things combine. The products of a neutralization reaction are always a salt and water. What happens in this reaction is hydrogen goes with hydroxide. When H and OH combine, that gives us H2O. That's the water. What's left over, the Na and the Cl, becomes the salt. So I'm going to show you another example of one for this reaction. So this is also a neutralization reaction. How I know that is I can see that this is an acid. How I know this is an acid is it's got hydrogen in front. This is a base. How I know it's a base is because it has hydroxide, or OH, at the end. So if I saw these two reactants, I'd be able to go, oh, it's got an acid, it's got a base, they're reacting with each other, it's a neutralization reaction. Then if I had to predict the products of this reaction, well, I know one of them is always going to be water. The products of a neutralization reaction, water is always one of the products. The other is a salt. So now in this instance, our salt would be Na2SO4 because sodium is the salt, or excuse me, is the cation of the base, so I put that there. Sulfate is the anion from the acid, so it would go here. Now, the reason why I have a 2 here on my sodium is because sulfate's charge is -2. Sodium's charge is +1, so when I crisscross those charges, again, this 4 is already on the sulfate, so I don't need to put a 1 outside of that from the sodium. But the 2 comes down from the sulfate, so this gives me my correct formula. This equation actually is not balanced. I don't know if you noticed that or not. So if you were asked to balance the reaction, you would have to do that. I have 2 sodiums on the right and only 1 on the left. So what I would have to do is I'd have to put a 2 in front of the NaOH. Then I would also have to put a 2 in front of the water, like this. So now my equation is balanced. You might be, if I give you a reaction, I would ask you to balance it. If it says just identify if it's a neutralization, or if it says predict the products, I probably won't ask you to balance that equation. Just pay attention to how the questions are worded, and it will tell you if you need to balance. I want you guys now, since we've kind of walked through 2 examples, I want you guys to try to predict the products of this reaction. So take a minute and do that. Alright, so now that you've had a chance to do that, again, the products of a neutralization reaction, how I know it's a neutralization is, I've got hydroxide, so this is a base. I've got hydrochloric acid, which is an acid because it starts with H. So I know this is a neutralization reaction. The products of a neutralization reaction, one of them is always water. Another one of them is the salt. So what's left over here is, if my H and my OH go together to make water, what's left over is my calcium and my chlorine. So I'm going to put those 2 together. Notice how in these other problems, sodium has always gone first. My cation from my base always gets put first in my products. So this would be Cl going with, Ca going with Cl. So this would be the products. The reason why there's a 2 behind the Cl is because calcium forms a +2 charge, so I have to crisscross the charges. Chlorine's charge is -1, which is why there is no subscript on the calcium. So that's what you should have done, and how I guess you would predict those products. This equation is also not balanced, so if I had asked you to balance it, you would need to do that. What I noticed first off is I've got 1 chlorine on the left and I've got 2 chlorines on the right, so I would need a 2 in front of my HCl here. Then to balance out my hydrogens and my oxygens, I would put a 2 in front of my water like that. Alrighty? So what we're going to start talking about is there is actually a new equation we're going to use, and this is that new equation. So on your notes page, make sure you get this down. Here's what these variables stand for. M sub acid stands for the molarity of the acid. V sub acid means the volume of the acid. Coefficient, or coef, is short for the coefficient of the acid from the balanced equation. Then over here on this side, this stands for the molarity of the base. This is the volume of the base over the coefficient of the base. Now, I want you guys to know, in this lesson, we're going to be doing stoichiometry. Okay, so we're going to be taking, we're going to have the molarity and the volume of an acid. We're going to be looking for the molarity of the base. So in these problems, you can still use your mole roadmap from our solution section if you want to do that. Both methods work. Doesn't matter which one you choose. This one, the reason why I'm introducing this equation is not to confuse you. It's because I think that some of you, or some students, when they forget to convert between milliliters and liters, you get the question wrong. Well, guess what? In this equation, you don't have to convert between milliliters and liters. If I'm given the volume of an acid in milliliters, I can leave it in milliliters, but I just have to know that my volume of my base will be in milliliters when I finish the problem. Or if I'm given both volumes of my acid and base, I can leave them both in milliliters and put them in there. So if, and this is some good information too, if the coefficient of the acid or base in the chemical equation is 1, then that means I can eliminate that from the equation. So if the coefficient of my acid was 1 in my balance equation, I can get rid of this variable, because anything divided by 1 is itself. Same thing for the base. If this was a 1, if I was plugging in 1 for the coefficient of my base, anything, these two things divided by 1 is still those numbers. So I can eliminate those values. And again, you can use milliliters in this equation. You do not have to convert to liters. Those are the benefits of it. If you're fine with converting and using the mole roadmap and doing all that, that's fine. You can use that. So here's the equation that we're going to try, and I'm going to show you how to use this equation. So here's how it works. Here's my problem. It says hydrochloric acid reacts with potassium hydroxide according to the following reaction. This reaction is already balanced for us. It says if 15 milliliters of 0.5 molar HCl exactly neutralizes 24 milliliters of KOH solution, what is the concentration of the KOH solution? So that equation that I just introduced to you, again, works exactly like we've been doing stoichiometry before. This equation is used a lot just in acid and base reactions, and what we would call acid and base stoichiometry or neutralization stoichiometry. So here's all that I do. I look at my problem and I find my molarity of my acid, the molarity of my base, the volume of my acid, the volume of my base, and plug in my values. So notice how here it says I have 15 milliliters of 0.5 molar HCl. Well, this, I know that HCl is my acid because it starts with H. So I'm going to take this 15 milliliters. It is a volume, so I'm going to plug it in there for volume of acid. This 0.5 molar HCl, that's the molarity of my acid, so I'm going to plug that in right there. Then it says it exactly neutralizes 24 milliliters of KOH solution. So 24 milliliters is the volume of my base because that's how much KOH I have. And this compound contains hydroxide, so I know that it is the base. So this number here is going to go right there. And the question that it asked me is, what is the concentration of the KOH solution? Well, that is what I'm going to be solving for. This molarity of base means that is concentration. Molarity is a type of concentration. That's what I'm going to be solving for. Then, what I plug in for my coefficient of acid and my coefficient of my base is, well, I look up at my balanced chemical equation. HCl has no coefficient in front of it, which means it's 1. So that means I would plug in a 1 here. The coefficient of my base, KOH, there's no coefficient there, which means it's a 1. So I would put that coefficient there. So here's what I would basically have for my reaction. I would have 0.5 times 15 equals, now I would have over my coefficient of my acid. Remember what I just said on the previous slide though. If the coefficient of my acid or of my base is 1, I can eliminate it. Because if I put a 1 right here, anything divided by 1 is going to be these numbers here. So I'm actually going to just get rid of those. I don't need it. Then I'm going to do the same thing on the right side. I do not know the molarity of my base. That's what I'm solving for. So I'm just going to leave in, I'm going to abbreviate that as M sub B. You could just write M, or you could leave in M sub base. This just stands for molarity of base. The volume of the base that I added is 24 milliliters. So I'm going to put in 24 milliliters, right like that. Now, the coefficient of my base is 1. And since I didn't need to use it on my acid side, because its coefficient was 1, I can do the same thing here. Now, I just solve this equation. Multiply these two numbers together and divide by 24. And that will give me my answer. Let's calculate that. What I get from my answer is 0.5 times 15 gave me 7.5. Then I divide both sides by 24, and what I get is, I get 0.3125 equals my M sub B. So that means this is the molarity of my base. In other words, the KOH solution that I had, its molarity, or its concentration, would be 0.3125 molar. Okay? Let's try another problem. So here's my next problem. It says sulfuric acid reacts with sodium hydroxide according to the following reaction. It gives me my reaction, and it is already balanced. If 20 milliliters of 0.4 molar H2SO4 exactly neutralizes 0.5 molar NaOH solution, what is the volume of NaOH solution required? So, I'm going to go through my problem, identify where my variables go. So, I have 20 milliliters of 0.4 molar H2SO4, and again, this H2SO4 is my acid. So that means I'm going to take this 20 milliliters, that is the volume of my acid. This 0.4 molar, that is the molarity of my acid. Then I'm going to look in front of my acid. What's its coefficient? Well, there's nothing there, which means its coefficient is technically 1. Then I'm going to go to this other side and start looking for these variables. Where's the molarity of my base? Well, it says it neutralized 0.5 molar NaOH. That 0.5 is going to go right there for molarity of base. The volume of my base is what I don't know. That's what it asked me about. It said, what was the volume of NaOH solution required? Well, so that's what I'm going to be solving for. Then I'm going to look, what's the coefficient of my base? Well, here's my base. It's NaOH. Its coefficient is 2, which means I'm going to put a 2 in right here. So let's set up our equation. So I'm going to have 0.4, which was the molarity of my acid, times 20 equals the molarity of my base, which is 0.5, times the volume of my base. I'm going to abbreviate that V sub B. You can do that if you'd like. Now, because the coefficient of my acid was 1, I do not need to put anything under this, because anytime I have 1 on the bottom of a fraction, I don't need it. If you'd like to put it on the bottom, you can. I'm not going to. But on this side, my coefficient of my base was 2. So I'm going to solve this equation right here. So how I would solve this is, I'm going to take 0.4 and multiply by 20. Then, in order to get this 2 out from under the bottom of this fraction, I would multiply by 2 on this side. I'm going to go ahead and solve that. And when I solve that, I get that 16 is equal to 0.5 times my V sub B. Well, now in order to get my V sub B by itself, I need to divide both sides by 0.5. So 16 divided by 0.5 gives me 32. That is my V sub B. This is my answer. Now the question might be, what are my units? Okay, because that's important. It says, what was the volume of my NaOH solution required? Well, if I wanted to know the units of this, remember in our PV over T equals PV over T equations, remember how the pressure and volume on those equations didn't necessarily have to be in atmospheres, or it didn't necessarily have to be in liters. What I always told you was, it doesn't matter what the unit is, as long as the pressure on each side is the same unit, or as long as the volume on the other side is the same unit. Well, in this problem, what was the unit of the volume of our acid? Well, it was in milliliters. Here's what that means. That means if I use milliliters here for my volume of acid, that means milliliters is going to come out from my volume of base. So that means this is milliliters. So I have 32 milliliters. If you were asked to move that or change that from volume of base, like instead of in milliliters, say change to liters, well, you would then need to divide that number by 1,000 to change it to liters. So it depends on kind of what you're asked to do in your problem. You'll still need to maybe convert after you're done. So here's what I want you guys to do. On your notes page, you have another problem that I want you to try. The answer will appear for you guys on the screen once you've tried that problem. If you have any questions, make sure you ask me, and I'll try and help you figure out what you did wrong. Again, if you don't like using this new equation, just use the mole map. For instance, in this problem, I was given the molarity and the volume of my acid. So I would start up in that top left-hand corner with molarity of A, and I would multiply by liters to get to moles. Then you would multiply by your mole ratio. Since I was asked to find volume of NaOH, if I was using this the old way in our stoichiometry, this would be B, this would be A. So I would change from moles of A to moles of B using my mole ratio. Then, to change to volume of B, I would divide by the molarity, which it gave me. So you can still use stoichiometry or the roadmap or this equation, it doesn't matter. I just want to give you guys some more skills, some more tools that you can use to help solve problems. That's it for our video today. Thanks for watching.